Good evening and good morning. And today I'd like to share the idea for thinking about the electrical noise excited by resistances. Resistance is represented in a character capital R, with which dimension is ohms, and it's well known the voltage squared RMS noise volt square per hertz density is described as 4kTr. But the reason for this description is rarely described in almost all of the textbooks, and so people and I, in my case, wonder how and why this 4kTr is come from. And in this video, I'd like to how I think the derivation of 4kTr to reasoning this description and easy to understand. Make it easy to understand. Electrical noise is a kind of electric signal measured by sometimes volts, like nanovolt, or RMS, or density of nanovolt per square root hertz. And noise is not signal. A signal is accompanied by in many cases voltage and current. Current or current density is, for example, J ampere per square meter per micrometer is the current, electric current through unit area, and this is derived by the electric force, which is defined by force per unit charge, coulomb, Newton per coulomb. In other words, electrical force, electrical field electric field E drift the current, produce the current density to its area. And one thing to note is the degrees of freedom. Capital N here, which means the particle movement is allowed, which direction or what kind of movement it is allowed to. For example, three-dimensional spaces, there are three directions and n equals 3. X, Y, Z elements of the movement is available. So sometimes the velocity of this particle is accompanied by Vx, Vy, and Vz, and overall velocity is Vx squared plus Vy squared plus Vz squared. 1 to 3 dimensional spaces movement represented by the velocity V is written by this equation. Or some molecules have constitute of two particles, and distance between these particles delta x equals vibrate, and this is 1 for n, and this delta x constitutes components can rotate, and this rotation rotation around an axis having 1 degrees of freedom, and also mass, these particles having a mass, and the mass center m to x1 x2 m1 m2 m1 x1 plus m2 x2 divided by m1 plus m2 is the x sub g is a mass center, and this has its velocity and acceleration v sub g, and this contributes to 1 degrees of freedom. So above all, rotation, vibration and rotation, and movements of the center of gravity. So this molecule has degrees of freedom. Sorry, this is Vxg, Vyg, Vzg, total 3 degrees of freedom, and 2 plus 3 equals 5. Rotation and vibration and velocity. For molecules constitutes of two particles has the degrees of freedom of 5. One particle with some spring attached and fixed to a wall, ideally having moving direction is x, and one direction dimension is 1, And under this has potential energy kx squared, x is the variation from the oscillation center, and also kinetic energy E sub k of half mvx squared. In this case, this system has n equal to 2 degrees of freedom. Energy is distributed. The total energy is distributed to two portions of energies. This degrees of freedom and energy distribution in one-dimensional oscillation is key to the derivation of 4kTr Vn squared RMS, volt squared per hertz. Next, I'd like to derive the relationships using these two concepts. Statistically, particle for 1 degrees of freedom have half kT joule of energy for 1 degrees of freedom. This is very famous, and you must know from your high school days. If you have a scientific curriculum, if you had some scientific curriculum. So if the system has 2 degrees of freedom, the total energy is kT. The unit equals joule. K is here, Boltzmann constant 1.38, 10 to the minus 23rd, joule per Kelvin. Kelvin is the absolute temperature, and joule is the energy. T is absolute temperature in Kelvin, so this is joule. And here you need to mention that joule is watt second, watt power and second time, power times time equals watt per hertz, because hertz is in 1/second, inverse of seconds is hertz. Dimension of the frequency. So joule is power per unit frequency. The system having some power for a frequency. The system having many distribution from frequency, its power is distributed, and but for 1 hertz on average it's some joule of power per hertz, which is this exchange is important. Joule equal watt per hertz. Then we know that electrons in metal at temperature T Kelvin, electrons in metals is able to contribute current conduction when excited at some T Kelvin. This is conductive material. Metal is conductive material, and no gap between conductance EC and E valence band. No gap. So in a metal, the electron energy field to the film energy at most, and some electrons is more than film energy distributed with some temperature. Electron film energy and some temperature T0, just T equals 0 Kelvin. There's no electrons more than film energy, but the finite temperature, at finite temperature T now, there are some electrons. So, and these electrons moving forward and backwards in the metal. This is metal, and electrons go and back. And then if there are some electric field, the electron is drifted through the direction backward the electron, because E equals minus E, charge equals minus E, so the force is inverse of the electric field. But for simplicity, current is with some charge moving to the electric field with a force. And there's the same of Q charged particles and repulsive forces surrounding them, and the carrier, like electron of some charge, electron holes drifted. Zigzag movements, but total current density is equals not zero. While with some electric field applied to the metal, without no electric field, current density plus direction and minus direction not zero, but totally these are no current exists on average. But electron has power and energy at temperature T Kelvin. But for simplicity, this is degenerated to one direction through X, one dimension, and there's one electron, two electron, three electron, repulsively force each other, and on average, one electron is restricted at some T temperature, but no electric field, of course magnetic field. Electromagnetic field doesn't exist in case the finite range of movement is allowed, but it's having energy. So this is like oscillation within repulsive force. Finite range oscillation, and which is like harmonic oscillator modeled by like this. This is x0, but this is x, and ek equals half of mb x squared. E potential energy is half of k x squared. The total energy is the sum of these, and each degrees of freedom half kT is distributed equivalently, and this harmonic oscillator model of electron in a metal at temperature T without electric or magnetic field is described like this, and having E total equals totally kT joule, and which is watt per hertz, kT watt per hertz. Because watt per hertz equals having said here, and then the energy is transferred to the power, capital volts squared over R, because this is watt per hertz, and this is watt per hertz. And this is energy of one electron on average in one-dimensional metal substance at temperature T without electric magnetic field, and this is voltage signal to external devices. If resistance R have this power energy, watt per hertz, power per hertz, this is described some noise voltage and the output resistance R, and the external loading resistor RL is connected to catch the noise. And we'd like to know how much energy is transferred and how much voltage is induced to the load resistance. In this simple model, if RL is the same value of the noise source resistance value R, the maximum transfer of the energy power is achieved. This is in the case of the impedance matching case. The maximum transfer is achieved when RL equals R, and this voltage oscillate by Vn, but R divided by R and R, so the value is half of Vn. So this V equal this V. External devices attached to the noise source catch the noise signal like this with this value, half Vn. So the power per hertz is written this is written 4R over Vn square. So if the resistance having noise Vn square, Vn var, Vn squared Vn var, and the resistance is R, this is Kt at maximum. Then you get Vn square volt square per hertz is defined by 4 Kt resistance R. Now we had reached to the goals. Energy Kt distributed to the kinetic and potential harmonic oscillator movement of the electron in a metal in one dimension is produce the noise, and at maximum the external device catches the noise with the voltage V equal half V or half Vn of the noise voltage RMS, which means RMS bar means RMS on average V squared. So the power V squared over R at maximum is catched from the source R. In this case, the resistance as a source, noise source, have the voltage noise of Vn square equal 4 KTR per volt square per hertz. Density, power density, this is said to be power density in volts squared. Like these, I myself, as far as I am concerned, I understand the derivation of 4 KTR, volt square per hertz. Power density in volts of resistance R. Resistance source is a repulsion force of between electrons, free electrons. At temperature T. At temperature T, 1 degrees of freedom particle having half kT Joule energy in principle. And finite range one-dimensional oscillation is distributed this half kT in two ways. So kT is the total energy of the electron noise. This maximum transfer is achieved by the external resistor, the same R, which is V square over R, and V equals half Vn. So the Vn square divided 4R equal exchange to kT, which means Vn square equal 4kTr.